In the following examples, we are asked to find the product of two trigonometric or polar formed numbers. So what we're going to do is we're going to apply what's called this product theorem that we're given here. Okay, and we're going to apply that product theorem, and we're going to then transform our answer into something that's in rectangular form. So something that's in a plus bi form. All right. So let's go ahead and take a look at the first example that we call number 8. All right, I'm going to write this in the abbreviated version, and it's going to say 5 cis of 45, and we're going to multiply that by 2 cis of 90. Okay, so if you look at the formula here, the formula in the compact version is just the product of these two R coefficients and then times the cis of the sum of the angles. So what we're going to do is we're going to take 5 and we're going to take 2 and we're going to multiply them. So that's going to give us 10. And then cosine imaginary sine, and then these two right here, we're going to add. Okay? You're going to add those two numbers. So 90 and 45 will give you 135. Okay, so that's not terribly difficult. So now what you do is you're going to find the cosine and then the imaginary sine of 135. So cosine of 135. Let's go ahead and take a look at our unit circle. Cosine of 135, and that is somewhere over here. Let me erase this. Cosine of 135 right here. Negative square root of 2 over 2. This is the cosine, and then this right here is the sine. Okay, so this is the cosine and the sine. We're going to need both of those. So let's take a look at our example back over here. The cosine again being the negative square root of 2 over 2. And we're going to add the imaginary, and then the sine again being the square root of 2 over 2, looking something like that. Okay, and now we're ready and we're set up for some very simple distribution right here. 10 times the negative square root of 2 over 2 gives me a negative 5 square root of 2 plus, and then 10 times the square root of 2 over 2, 10 divided by 2 is 5 again, 5 square root of 2i. So that's what this first answer looks like for this problem number 8. Okay, so I'm going to go ahead and clear the screen. So if you'd like, you can pause right now, but otherwise give me a second to clear the screen. Okay, now here's another example. Again, we're applying the same product theorem. So we're going to once again multiply the 7 and the 2, and we get 14. So it's going to be 14 cosine imaginary sine, the cis, and then these two right here, the 150 and the 90, we're going to add once again, and that's going to give us 240 degrees. And so we're going to take that 14, we're going to multiply it by the cosine and then the imaginary sine of 240. So now we're going to navigate over to the unit circle, 240 degrees. This is the cosine, and this right here is the sine. So the cosine is negative 1/2, and the sine is the negative square root of 3 over 2. All right, perfect. So now let's take it back to our problem. Right over here. All right, and the cosine, again, we recall was what? Negative 1/2 plus the imaginary unit, I, and then the sine was the negative square root of 3 over 2. Look just like that. Now we're ready to do our simple distribution. 14 times negative 1/2 is negative 7. And 14 times a negative square root of 3 over 2 is negative 7 square root of 3 with an I added on there. Okay, so this is what the polar form would look like in rectangular form for the initial product that we were given. This is what it would look like in rectangular form. So two really, simple examples of applying this quote-unquote product theorem. Not much to figure out. Again, you really do need a working knowledge of the unit circle, or at least have a copy of the unit circle in order to get this done. So, as always, if this video was helpful, be sure to like and subscribe.